Welcome back, everyone, to the deep dive. This time, we're going to tackle, well, the core concepts of programming. And
sounds fun.
it's, more than just like lines of code, right? It's how to think like a programmer. And that's surprisingly useful.
Right.
Even if you never actually write, a single line of code yourself.
Yeah, for sure.
So the guide for this journey is, well, it's a Spanish textbook, actually,
Oh, wow.
called Fundamentos de Programación, Libro de Problemas.
Interesting.
So what I think is really fascinating about this book is how it focuses on practical problem solving and designing algorithms.
Yeah, and it uses this pseudocode language called UPSM 2.0,
Okay.
which is designed to be like super readable, and you can apply it to
Yeah.
a bunch of popular programming languages.
So we're not really learning to code in like a specific language, right?
Right.
We're kind of getting that like universal thought process behind it.
Yeah, the authors, they emphasize this problem-solving phase, right?
Okay.
First, you got to understand the problem, obviously.
Yeah.
Then you design a solution conceptually, and then finally you got to specify all the steps with an algorithm.
Algorithms. See, that
These are
sounds
really
complicated.
Right.
But isn't that just a fancy word for like a set of instructions?
Yeah, pretty much.
Like a recipe or something?
Exactly.
Right.
Exactly. And the book breaks it down even further
Okay.
with this really helpful tip. Think about any problem in terms of input, process, and output.
Okay, so input is what you start with.
Yes.
Process is what you do to it.
Yep.
And output is...
The results.
Okay.
Yeah.
That makes sense.
So to make this a bit more clear, the book gives a simple example.
Okay.
Calculating the area of a rectangle.
Oh. Well,
So let's just say you have a rectangle. It's 5 units wide and 10 units long.
so the input would be the width and length.
Exactly.
The process would be multiplying them together.
Right.
And the output would be the area, which is 50.
Perfect. And the book represents these algorithms using tools like flowcharts and pseudocode. It's basically just different ways to map out that logic visually or with text.
It's kind of like having different blueprints for building your solution.
Exactly.
Each one shows the steps in a slightly different way.
Yes.
But the goal is,
Clarity.
clarity.
Yeah.
Okay, I get it.
Once you have your algorithm all planned out, you need to think about those building blocks you'll use,
Okay.
which are called data types.
Okay.
So these tell the computer what kind of information it's dealing with, whether it's numbers, text, or even like true-false values.
So like integers for whole numbers?
Yep.
Real numbers for decimals, strings for text.
Exactly.
This reminds me of like setting up a spreadsheet.
Yeah.
You choose the data type for each column, right?
Yeah, that's a really good analogy.
Okay.
So, and then you got constants and variables, right? Constants are these fixed values that never change throughout the program. Okay.
Whereas variables, they can change their values.
Okay, so if our rectangle problem always used a width of 5, that could be a constant.
Yes.
But if, we let the user input any width they wanted,
Right.
that would be a variable.
Precisely.
Okay.
And the book actually goes a step further.
Okay.
It distinguishes between literal constants, like the values you write directly in the code, like 5, and symbolic constants, which are given a name, like width.
So it's like using the word width instead of just always writing 5.
Exactly.
Okay.
Which makes your code more readable and easier to modify later on.
That makes a lot of sense, especially if, your code is long and complicated.
Right. Exactly.
Now, the book also emphasizes structured programming.
Yes.
Which is all about writing, well-organized programs
Yes.
that are easy to read and modify.
It's not just about getting the code to work. It's also about making it look nice.
And being maintainable.
Yeah. Elegant.
Elegant, yeah. They introduce this concept of proper programs, which essentially means a program with a clear path from start to finish.
Okay.
And, it avoids any confusing jumps or tangled logic.
It's kind of like making sure your recipe steps are in a logical order.
Exactly.
You wouldn't tell someone to, like, frost the cake before baking it, right?
Exactly.
Okay.
And the book uses this famous Boom-Jacopini theorem to highlight that you can build any proper program using only 3 basic structures.
Okay.
Sequential, selective, and repetitive.
Okay, so sequential is just doing things like one after another.
Yes.
Selective is like an if-then statement where the program's making a decision. Right. What about repetitive?
Repetitive structures, or loops,
allow
a program to repeat a set of actions multiple times, which is, super useful for things like processing lists of data or performing calculations.
That sounds like it would save a lot of time and effort
Yeah.
instead of writing the same code over and over.
Ex-
You just tell the program to repeat it
mm-hmm.
until a certain condition is met, right?
Precisely.
Right.
And the book uses, all these real-world examples to demonstrate these structures,
Sure.
like reading a series of temperatures, calculating averages, and even validating dates.
Wow.
So you can see how these seemingly simple structures can be combined to solve incredibly diverse problems.
That's really cool.
Yeah.
So we've got our building blocks, right?
Yeah.
Algorithms made up of sequential, selective, and repetitive structures.
Right.
It's like we're learning the grammar of a programming language, kind of.
Yeah, that's a great way to put it.
Right.
And just like with grammar, mastering those structures, it really lets you create incredibly diverse programs.
Yeah.
The book, brings this to life with these practical examples.
Oh, like what kind of examples?
Okay, so imagine you're building a program to analyze weather data.
Okay.
And specifically, you want to find the highest temperature recorded over a certain period.
Okay, so our input would be like a list of temperatures.
Right.
And then the output would be, well, the highest one, obviously.
Exactly.
What about the process? How would we find that highest temperature?
Okay, so that's where those three structures come in.
Okay.
We'd start sequentially by assuming the first temperature is the highest.
Okay.
Then we'd use a loop, which is a repetitive structure,
Okay.
to go through all the rest of the temperatures.
And within that loop, what happens?
So within the loop,
Yeah.
we use a selective structure, an if statement,
Okay.
to compare each temperature with our current highest.
Okay.
And then if that new temperature is higher, we update our highest temperature value.
Oh, so it's kind of like keeping a running tally
Yeah.
of the leader in a race.
Exactly.
Right.
Each time someone runs faster, they become the new leader.
And that final highest temperature is our output.
Exactly.
Gotcha.
The book also talks about something called control flow,
Control flow, okay?
which is basically the order in which those instructions are executed.
So with sequential structures, it's straightforward, right?
Yeah.
One instruction after another.
Exactly.
But those loops and if statements, they make things a little more dynamic.
Right.
The program has to
Sure.
make decisions based on the data.
Precisely.
Right.
And the book explains all these different types of loops, like for loops,
Okay.
for when you know exactly how many times to repeat something,
Yeah.
and while loops, for when you repeat until a certain condition is met.
Okay.
It can get kind of detailed.
Right.
But the key is understanding that control flow is like navigating a path through your program, making sure things happen in the right order.
Okay. Now, you mentioned before that good programmers, they not only make their code work, but they also strive for clarity, right?
Yes.
How does the book address that?
So one important thing is using comments in your code.
Comments, okay.
So these are basically notes for us humans.
Right.
The computer completely ignores them, but they help explain what different parts of the code are doing.
So it's like leaving notes for yourself
Yeah,
or for other programmers who might have to work on the code later.
exactly. Like
Okay.
imagine you're trying to understand a recipe written in a foreign language.
Yeah.
Comments would be like having translations and explanations sprinkled throughout.
Right, to make everything much clearer.
Exactly.
Okay, I see. Now, I'm curious how the book tackles handling large amounts of data.
Yeah.
It's one thing to work with a few numbers, but what about real-world situations
All right.
where you have tons of information?
That's where data structures come in.
Data structures, okay.
They're basically like specialized containers for your data.
Okay.
So instead of throwing all your data into one giant box,
Right,
you can use different containers, shelves, and drawers.
to keep things organized.
Exactly, you got it.
Okay,
So the book looks at specific data structures like arrays and records. Arrays are like these ordered lists where each item can be accessed by its position.
okay,
So like, think of a row of houses, each with their own unique address.
okay. And what about records?
Records let you group different data types together.
Okay,
So it's like having a file cabinet where each drawer holds a different type of information about a person,
okay.
like their name, their address, and their contact details.
So basically, data structures are all about bringing order to data.
Exactly.
So our programs can actually work with it effectively.
Precisely.
Okay.
And the book goes beyond just explaining, what these structures are. It shows you how to use them to solve practical problems.
Oh, okay. Like what kind?
So let's say you're building a program to manage like a library catalog.
Okay.
You could use arrays to store lists of book titles
Yep.
and author names, and then records to store all the information about each book.
Right.
Like the title, author, publication date, genre, all that.
That makes sense.
It's like having a well-organized library where you can easily find any book you're looking for.
Yeah.
And then going beyond arrays and records, the book also talks about files,
Files.
which
Okay.
are used to store data even when the program isn't running.
Oh, right, because we don't want to lose all our data
Exactly.
every time we close a program.
Exactly. Files let you save that data to, like, a hard drive.
Right,
So it's there when you need it again.
like saving a document
Exactly. You got it.
on your computer. Yeah.
You can close it, open it later, and all your work is still there.
Okay, so we've covered ways to store and organize data,
Mm-hmm.
but what about actually doing something with it?
Right. So that's where algorithms really come into play.
Okay.
And the book dives into specific algorithms for tasks like sorting data, searching for specific information,
Right.
even merging different data sets together.
You know, sorting algorithms always make me think of those videos where they like organize Skittles by color.
Yeah.
It seems so tedious, but computers can do it so fast.
Yeah. Super fast. And there's all these different sorting algorithms,
Right.
each with their own, like, strengths and weaknesses.
Okay.
Some are super simple to understand,
Yeah.
but not very efficient, for large data sets.
Right.
While others are, more complex, but way faster.
Who's like choosing the right tool for the job.
Right.
You wouldn't use a hammer to screw in a light bulb.
Exactly. And the book does a great job at, like, explaining the core idea of sorting and why it's important without getting too bogged down in all the technical details of every single algorithm.
Okay, what about searching?
Okay, so for searching,
Yeah.
one simple method is called linear search,
Okay.
which is basically just going through the data one by one
Right.
until you find what you're looking for.
That sounds straightforward,
Yeah.
but maybe not the most efficient, especially for large data sets.
You're absolutely right. For sorted data,
Yeah.
there's this way more efficient method called binary search.
Okay, binaries.
It's like looking for a word in the dictionary. You open it up in the middle,
Yeah.
then you decide whether to look in the first half or the second half based on alphabetical order.
So you eliminate half the possibilities with each step.
Exactly.
Makes sense.
And finally, the book covers merging, which is combining multiple data sets into a single sorted data set.
Okay.
This is used a lot with sorting algorithms, especially in approaches like merge sort, which we talked about earlier.
So it's like you have two stacks of sorted papers.
Yeah.
And you're combining them into one big sorted stack.
Exactly.
You repeatedly compare the top elements and take the smaller one.
Yes, exactly.
Okay.
Might seem like a detail.
Yeah.
But merging is really powerful,
Okay.
used in tons of real-world applications.
Why?
Think about, like, how social media platforms merge your friends' updates to create a single chronological feed.
Wow, I never thought of it that way.
Yeah.
It's amazing how all these seemingly abstract programming concepts,
I know, right?
they're actually working behind the scenes
Yeah.
in so many aspects of our life.
Absolutely. And that brings us to one of the most fascinating
Okay.
and sometimes mind-bending concepts in programming: recursion.
Oh, yeah, you mentioned that earlier.
Yeah.
It's when a function calls itself, right?
Precisely. It's like those Russian nesting dolls,
Right.
where each doll contains a smaller version of itself.
Yeah, I could see how that could get confusing.
Right.
How does the book explain this?
So the book, it tackles recursion head on, with clear examples like
Yeah.
calculating factorials
Okay.
and generating Fibonacci sequences.
Okay.
It can seem a bit magical at first, I'll admit that.
Right.
But once you kind of grasp that idea
Right.
of defining a problem
Mm-hmm.
in terms of itself, it can lead to some really elegant solutions.
You know, it's interesting how this idea of breaking down, complex problems
Yeah.
into these smaller self-similar parts, it kind of echoes what we've seen with, algorithms and data structures.
There's a common thread.
There's a common thread, yeah.
It's a fundamental approach, not just in computer science,
Right.
but just problem solving in general.
Yeah, for sure.
And that brings us to another major paradigm shift the book explores: object-oriented programming.
Okay, I've heard that term a lot, but to be honest with you,
Yeah.
I'm still not quite sure I get it.
Okay, so it's all about modeling software around these real-world entities, and their interactions.
Okay.
Imagine, like, building a virtual world
Yeah?
where objects behave just like their real-world counterparts.
Okay.
So instead of thinking about procedures and data as, like, these separate things,
Yeah.
you think about objects that contain both.
So in our zoo simulation that we're talking about,
Mm-hmm.
instead of having separate code for, an animal's name, species, and actions.
Right.
We could have like an animal object
Exactly.
that contains all that information and can perform actions.
Precisely. And the building blocks of this approach
Yeah.
are classes and objects.
Yeah.
A class is basically a blueprint
Okay.
that defines the characteristics and behaviors of a particular type of object.
So our animal class, would that specify things like name,
Yes.
species,
Yeah.
age, and actions like eating or sleeping?
Exactly. Those are called attributes and methods.
Okay.
Attributes are like the data associated with the object.
Right.
And methods are those actions it can perform.
Okay, so I'm starting to see how this all fits together.
Yeah.
So what is an object then?
An object is an instance of a class.
Okay.
So it's like creating a specific animal from our animal blueprint. We could have an object called Leo.
Yeah.
And that's an instance of the animal class, right?
Okay.
With his own name, species, age, weight, all that.
So Leo would inherit
Yes.
all those general characteristics and behaviors from the animal class,
Exactly.
but also has his own specific values for those attributes.
Precisely. And this inheritance it's a powerful mechanism, because it allows you to create new classes that are specialized versions of existing ones.
Okay.
So we could have a subclass called lion
Right.
that inherits from animal,
Okay.
but also has, unique attributes or methods that are specific to lions.
That's okay, like main size?
Yes.
Or roar, or...
Yeah, things like that.
This kind of reminds me of how biological classification works,
Oh, yeah, that's a good point.
You have like the kingdom, phylum, class,
Right.
order,
Right.
family, genus, species.
Each level inherits characteristics from the one above it.
Exactly. But
Yeah.
also has its own unique features.
That's a great analogy.
Yeah.
And this brings us to another key concept,
Okay.
polymorphism.
Polymorphism. Okay.
It sounds complicated, but it really just means many forms.
Okay. Break that down for me.
Okay, so think about, that make sound method from before.
Yeah.
All animals inherit that method from the animal class. Yeah. But they all make different sounds, right?
Right. A lion roars, a bird chirps, a snake hisses.
Exactly. So even though they share the same method name, they can implement it differently
Yeah.
to produce their unique sounds.
So it's like having a single command, make sound.
Yeah.
But each animal interprets and executes it
Right.
in its own way.
Precisely. So polymorphism allows objects to behave differently based on their specific class,
Right.
even if they share that common method.
That's pretty cool.
It is. It's super cool. And this flexibility is what makes object-oriented programming so powerful for modeling these complex systems.
Right.
The book also highlights concepts like encapsulation and abstraction.
Oh, more new terms.
I know. But just think of encapsulation as putting a protective shell around an object's internal workings.
Okay.
It helps to keep the data safe and organized,
Yeah.
Abstraction is about simplifying things by hiding unnecessary details.
Okay.
It's like how you use a remote control. You don't need to know all the electronics inside.
So abstraction kind of lets you focus on the what
Exactly.
rather than on the how.
You got it.
And does this tie into modularity, which we were talking about before?
Absolutely.
Okay.
Modularity, breaking a program down into those smaller, self-contained units.
Right.
It goes hand in hand with these concepts.
Okay.
It's like building a house room by room,
Right.
each with its own specific function.
Okay. So this is all about managing complexity,
Yeah.
making the code, easier to understand, modify, and reuse.
Exactly. And it echoes those principles of good programming we've been talking about throughout this whole deep dive.
Yeah.
Clarity, efficiency, and structure.
It's amazing how much we've covered just from this one textbook.
It is, right?
We went from the most basic building blocks
Yeah.
all the way to object-oriented design,
I know. It's a lot.
which is incredibly powerful.
It is, and it's really a testament to the book's structure and how clearly they explain things.
And what's really valuable,
Yeah.
is that these core principles,
Right.
they're applicable way beyond any specific programming language.
You can take these with you anywhere.
Yeah, so even if someone never writes a line of code,
Yeah.
just understanding these concepts
Right.
can help them think more systematically,
Absolutely.
solve problems more effectively. It's almost like learning a new way of thinking.
It really is.
Yeah.
And, who knows? Maybe this deep dive has sparked a curiosity in someone out there
Yeah,
who will go on to create something amazing with code.
that would be awesome.
It would.
Well, on that inspiring note,
Yeah.
I think we've reached the end
Yeah, I think so.
of our deep dive
It's been a journey.
into programming fundamentals.
It has.
It's been great having you.
It's been a pleasure.
And
Yeah.
to all our listeners out there,
Mm-hmm.
remember the world of programming.
Yeah.
It's constantly evolving.
It-
But these core concepts, they really do provide a
Yeah.
solid foundation
They do.
for understanding and even shaping,
Mm-hmm.
the technology
What technology that surrounds us.
that surrounds us. Exactly.
Yeah.
So until next time,
Until next time,
keep exploring,
keep learning
keep learning,
and keep diving deep.
and keep diving deep into those fascinating topics.
Yes.